This is Truss Reaction Forces 2 homework debriefing for aerospace engineering. You're only to calculate the reaction forces for these three trusses. Of course, I say only. I have a load of 200 newtons. We're going to use units of newtons and units of meters for forces and distance. Point A is this pivot point here, or pinned point. B is the roller over on the right, and you're to identify the reaction forces A and B. The sum of the forces in a vertical direction have to add up to 200 newtons total. But there's a moment about pivot point A that has to be canceled by a moment caused by B, a force acting through B. So I'm going to slide this 200 newtons until it's perpendicular to the directions from A to the force. That means it'll be a distance of 1 meter as a value of R, 200 newtons for the value of F in the negative direction, in the clockwise direction. So the moment caused by this 200 Newton load is negative 200 Newton meters. That is the moment. It is the amount of twisting force about this axis point. It has to be canceled by 200 Newton meters of positive moment. And the distance from A to B is 1, 2, 3, 4, 5 meters. If I take 200 and I divide it by 5, I get 40. So the upward force, the reaction force through B in the y direction is 40 newtons. That cancels the clockwise moment caused by the load acting here at point C. Next, the sum of all the forces in the vertical direction have to add up to 0. I have 200 newtons pushing down on the structure. At point B, I have 40 newtons pushing up. 200 minus 40 means there has to be an upward reaction force to point A of 160 newtons. There were no horizontal loads being applied, so there are no horizontal reaction forces acting through point A. Number 2. I have a 250 Newton load applied at 1, 2, 3 meters above point A. So after I slide this force along its line of action backwards until it's directly above point A, making the value of R perpendicular to the direction of F. I should say the direction of R. I see I have 1, 2, 3 times 250 is clockwise moment of negative 750 Newton meters about A, caused by this load. The only way to cancel that is by an upward force acting through B, creating a positive moment. The distance from A to B is 1, 2, 3, 4 meters. So I have to take 750 Newton meters and divide that by 4 meters. And I have an upward force of 187.5. You can go ahead and call that 188 newtons. That is the reaction force through B in the y direction. There is a horizontal force of 250 newtons. The sum of all the forces in the horizontal direction have to add up to 0. So the reaction force through A in the horizontal direction has to be negative 250 newtons. The sum of all the forces in the vertical direction also have to add up to 0. So if I'm pushing upwards on this structure through point B with a force of 188 newtons, I must be pulling down on point A with an equal magnitude force. Call it 188 newtons. That's number 2. Number 3, I have a load of 200 newtons being applied halfway between A and B. In addition, I have a 300 Newton load being applied up here at this upper vertex. Well, I have 2 moments, and I have to sum them together. They are both clockwise or negative moments about point A. By the way, if I chose point B to be my axis of rotation instead, and I'm allowed to do that, then this 200 Newton load would be a positive moment, and this 300 Newton load would be a negative moment. From B, this would be a positive 90 degrees. From B, this would be a negative 90 degrees. So be aware that when you choose your axis of rotation, it changes the geometry as well. However, my habit has always been to work to point A, and I'm going to continue to do that. 2 meters from A to this 200 Newton load force when it is perpendicular. The direction of F is perpendicular of the direction from A to F. So that's 2 times 200 in the negative direction is negative 400 Newton meters. For the load up here, I slide it backwards along its line of action until it's directly above point A, and I see R is now 3 meters when it is perpendicular, when the direction of R is perpendicular to the direction of the load. So that's 3 times 300 is 900, also clockwise or negative. So I have negative 900 Newton meters of moment. Summing them together, I have negative 1,300 Newton meters of moment acting about point A. All of that can only be canceled by an upward reaction force acting through point B, 1, 2, 3, 4 meters from A to B. So negative 1,300 Newton meters divided by 4 is a value of 325 newtons acting upward to B to cancel the moments caused by these two loads. The sum of all the forces in the horizontal direction have to add up to 0. So if 300 newtons is pulling the structure to the right, then the reaction force at A must be pulling 300 newtons to the left. So the reaction force at A is, I'm going to use a minus sign to show that it's to the left, minus 300 newtons. The sum of all the forces in the vertical direction have to add up to 0. So if I have a 200 Newton load pushing down and a 325 Newton load pushing up, then I need a reaction force through A that is 125 newtons pushing down. And by the way, be careful when you turn in answers. If you say that it's negative in the downward direction, that is a double negative. So you should distinguish that you're not intending to have this like this is a negative downward direction. Just make it clear somehow. Hopefully you listen to my words and you understand that this is negative 125 newtons. Great, which I'm illustrating by drawing the arrow pointing down. This concludes the debrief on Truss reaction forces 2 homework.